This question says, for what value of x is g of x equals 7? So we have to remember that the notation g of x is representing y. So this is saying that y equals 7. And the question says, for what value of x is y 7? So we're going to go up here on our y scale, and we're going to find out where we have a y value of 7. We have a y value of 7 here. So if I go across on both sides, the only point on the graph that has a y value of 7 is right here, and the x value that matches that is negative 7. And so x equals 7, negative 7 is when g of x is equal to 7. This question says, find the center, radius, intercepts of the circle with the given equation, and then sketch the graph. So this equation, this is an equation of a circle. However, it's in general form and not our standard form. So what I want to do first is I want to move it into our standard form. So let's write down the equation. We have 3x squared plus 3y squared minus 18x plus 24y plus 27 equals 0. And the first thing I notice about this is having a coefficient of 3 on our x squared and our y squared. In general form, we typically have x squared and y squared with no coefficients. So I'd like to get rid of that first. I'm going to do that by dividing all the terms by 3. That gives me x squared plus y squared minus 6x plus 8y plus 9 equals 0. And now I'm going to group the x terms together, group the y terms together, and move the constant to the other side. So if I group the x's together, I'd have x squared minus 6x. The y terms would be y squared plus 8y. And then I'll move that constant to the other side by subtracting 9. Now once I've grouped the x's and the y's together, then I'm going to use completing the square. I'm going to start with the coefficient on the x, which is negative 6. Let me start over here. I'm going to divide that by 2 and square it to get the magic number. Negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So that's the number that I want to add to the x group. That's x squared minus 6x plus 9, and whatever I do to one side, I need to do the same thing to the other side. Now I want to repeat that for the y group. So for the y group, I'm going to start with the coefficient on the y term. That's 8. 8 over 2 squared. 8 over 2 is 4, and 4 squared is 16. So I want to add a 16 to the y group. And whatever I do on one side, I need to do the same thing on the other side. And now I've put the number in that will complete the square. And this will factor nicely into x and x, 3 and 3, minus and minus, which then can be written as x minus 3 squared. Something similar happens with the y group. That factors nicely into y and y, 4 and 4, both pluses, and y plus 4 times y plus 4 is y plus 4 squared. Then the constants will combine to be 16. So I've taken my circle from general form into standard form, And now it's easier for me to find the center and the radius. So the center is 3, -4, and the radius is 4. And I can spend a little bit more time on how I got those values. The standard form of a circle is x minus h squared plus y minus k squared equals r squared. So if I line that up with my standard form, x minus 3 squared plus y plus 4 squared equals r squared, I can very easily see that h is 3. That's how I got the 3. With this y plus 4, it looks a little bit different because I have y minus k, but every addition can be written as subtracting the opposite. So this is the same thing as y minus -4. And so now you can see that your k is -4. And then finally you have r squared equals 16. If you square root both sides, you get r equals plus or minus 4, and the radius is a positive value. It's a distance, so that will be 4. So we have the center and the radius. And the last thing we want to do is find the intercepts and then draw the graph. I think drawing the graph might be a little bit easier, so we'll do the graph first and then the intercepts. So for the graph, I would plot the center. The center is 3, -4, should be here. And then I'm going to go the distance of the radius up, down, left, and right. So that's up 4, right 4, down 4, and left 4. And draw the circle from there. And I know mine doesn't quite look like a circle, and that's because my grid is a little bit off kilter. It's not perfect square. You can kind of see it's longer than it is tall. So that's why it doesn't look exactly like a circle. So then I want to find the intercepts. So I'm going to use my equation in standard form, x minus 3 squared plus y plus 4 squared equals 16. To find a y-intercept, I let x be equal to 0. I substitute a 0 in, 0 minus 3 squared plus y plus 4 squared equals 16. -3 squared is a positive 9. I'm using a square root method to solve, so I'm going to isolate this square by subtracting 9 on both sides. So that gives me y plus 4 squared equals 7. And then I'll square root both sides, and that gives me y plus 4 equals plus or minus square root of 7. And then I'll subtract 4 on both sides to get y equals -4 plus or minus square root of 7. So those are my y-intercepts. So then to find the x-intercept, I'm going to let y equal 0. So in my equation, I've got x minus 3 squared. Substitute a 0 in for y. That gives me x minus 3 squared plus 16 equals 16. I'll subtract 16 on both sides, and that gives me x minus 3 squared equals 0. And then I'll square root both sides. X minus 3 equals plus or minus 0. And I'll add 3, and that's x equals 3. And you can kind of see that with the graph that we drew. Do you see how our X intercept touches right there at 3? So it matches, and we have 2 Y intercepts just like we have in our graph. This question says, classify the given function as a polynomial function, rational function, root function, and then find its domain. Write the domain in interval notation. So for this function, we have h of t equals the cube root of -2 t to the 4th plus 9. And we would categorize this as a root function because it has a variable underneath the radical. Now with root functions, it breaks out into 2 more categories, and you want to have these categories being even root and odd root. And what that's mentioning, or what that's pertaining to, is the index on the radical. So the index on this radical is a 3, so that makes this example an odd root. Now the thing that's interesting about odd roots is that there are no restrictions, meaning that you can take the odd root of a positive number and get a real number. You can take the odd root of 0, and that's 0, which is a real number, and you can take the odd root of a negative, and that's a real number. So we have no restrictions on odd root functions. So when we have no restrictions, that means that we have no restrictions on the domain, and your domain will be all real numbers, which is -infinity to infinity. So the domain of h of t equals cube root of -2 t to the 4th plus 9 is -infinity to infinity.